Hello everyone, this is Mr. McMillan, and I'm here with some problems worked out on the worksheet on angles and arcs and circles. This was assigned a few days ago, but we went over this together in class just to kind of help bolster our knowledge of this material. We'll continue working on this as we go along. So in the first four questions, it says to find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. So in number one, it wants us to find what the measure of arc UWV is. And so anytime that it wants me to find the measure of an arc or anything else like that, what I like to do is draw that out on the diagram or put an X there or whatever else. So this wants the measure of arc UWV. So we start at U, then we have to go to W, and then we go to V. And so we're looking for that arc that I just put in red right there. Now, you'll also notice that we have arc UV, which is 86 degrees. And if you notice, arc UV and arc UWV make up the entire circle. Well, what do you know about the arc measures or the angle measures in a circle? What do they all add up to? Well, a circle is 360 degrees around. So that means to find the measure of UWV, you know that 86 plus whatever it is 360. So you take 360 minus 86. So the measure of UWV must be equal to 274. All right, so let's look at number two. Number two wants us to find the measure of angle FDG. So angle FDG is here. And you'll notice that that type of angle is at the center, so it's a central angle. So since we're looking at a central angle, if we can determine what the arc across from it is, we can determine what the angle measure is. Now in this picture, how can you use the 50-degree measure in order to find what arc FG is? Well, you should be able to see that that EG is a diameter. So this here is a diameter. Now, what does a diameter do to a circle? Well, a diameter splits the circle in half. So that means that this arc here is a semicircle, and the other arc is as well. Now, if you cut a circle in half, what does the arc equal in total? Well, that would be 180 degrees. Well, if we know that this whole thing is 180 and this part is 50, how can we find the measure of FG? Well, we can take 180 and subtract 50 and get 130 for the measure of arc FG. Now, since we know that the central angle is equal to the arc, then we know that the measure of angle FDG must also be 130 degrees. All right, number three. Number three wants us to find the measure of angle HIG, excuse me. So angle HIG would be here. Now, if you'll notice, angle HIG is a central angle, okay? We also see that we have arc EF here, which is 75 degrees. Well, the angle directly across from X would also be the same because those two angles are vertical angles, okay? So this is a vertical angle with X. Well, this angle is also a central angle, so we know that it has to be equal to 75 degrees. And these are vertical. The vertical angles are congruent. So that means that our missing angle that we wanted to find must also be 75 degrees. All right, and number four says to find the measure of URT. So we start at U, we go to R, and then we go to T, and that's what we want to find. Now there's a couple different ways to do this one because all of these arcs or angles have a measure. So you'll see here that this has a 65-degree measure, so the arc must also be a 65-degree arc. So there are a couple ways you can do this. The first, you can see that UR is 90, RS is 65, and ST is 60, and they're all part of URT. So you could take 90 plus 65 plus 60, or you can also see that the only thing that's not included in UT that's on the circle is this 145-degree angle or arc. So you could take 360 minus 145 to get your remaining arc. So the measure of URT, regardless of which way you go, will end up being 215 degrees. Okay. All right, so let's look at number 5 and 6 here. It says to find the measure of the arc or angle indicated. So in number 5, what does it want us to find? Well, the question mark here says we want to find angle V. Now, what type of angle is angle V? Well, to do that, we need to figure out where the vertex is, and the vertex is on the circle. And when we have a vertex that's on the circle, then that means we are dealing with an inscribed angle. Now, an inscribed angle changes depending on if you have the angle or the arc. So we want to find the angle and we have the arc. So our formula, and this is our arc, by the way. So our formula for an inscribed angle is the angle is equal to 1/2 of what the arc is. Well, we don't know what our angle is, but we do know what our arc is, which is 156. So we take 156, take half of it. 1/2 times 156 is the same thing as doing 156 divided by 2. So that means that the measure of angle V is 78 degrees. Number 6, what do you want to find in number 6? Well, you have an arc here that you want to find, which is at BD. And you'll also notice that you have a 60-degree angle here. And that 60-degree angle is important because that 60-degree angle is associated with this arc in some way. So let's figure out what type of angle that is. So our vertex is on the circle. So if it's on the circle, then this would be an inscribed angle. And we know that the angle is equal to half of the arc. But we already know what the arc or the angle is. We want to figure out what the arc is. So if the angle is half the arc, that means that the arc must be twice as large as the angle. So our arc is arc BD. And then we take 2 times our angle, which is angle C, which is 60 degrees. So the measure of arc BD is equal to 120 degrees. Oops. All right. apologize for the lights. All right, so let's flip on over and look at number 7. So number 7, what does it want us to find? Well, it wants us to find arc KL. Now you'll notice we don't have any inscribed angles for arc KL. So we need, or any type of angle that's associated with it. So there's a couple different ways we could do it, but I'm going to do the way most people will end up doing it. So on number 7, if we have this arc, and we know this arc, I can try and find arc LM to determine the remaining arc that's missing. And in this case, we can do just that because our arc LM is associated with angle K. Now, angle K is inscribed because it's on the vertex. So that means that if I want to find arc LM, I need to use one of our formulas. So we know that the arc measure is equal to twice what the angle is. So our arc is LM, which is 2 times 32. So arc LM is 64. Now that we know that arc LM is 64 and we know KM is 156, the only remaining arc that we need to find is KL. So all of those arcs add up to 360. So to find arc KL, we take 360 minus 156 minus 64. So 360 minus 156 minus 64 will get you 140 degrees. All right, number 8. Number 8, it wants us to find angle N. And angle N has a vertex that's on the circle, so it's an inscribed angle. Now, when we're looking at an inscribed angle, we need to know what the arc is in order to determine its value in most cases. So let's do just that. So we need to find arc LM. Well, we have NM and NL. So to find arc LM, we know they add up to 360. So arc LM must be equal to 360 minus 130 minus 148, which means arc LM is equal to 82 degrees. Now, since this is an inscribed angle, we know that the inscribed angle is equal to half of what the arc is. So our angle is angle N. It's 1/2 of 82, which is our arc. So it is 41 degrees. Number 9. Number 9, we're looking for angle B, and angle B is an inscribed angle. So since angle B is an inscribed angle, we need to know what arc we need to find in order to determine it. Well, here angle B starts at J and then goes to C because those are the lines that connect the angle together. So if we could find arc JDC, we could determine what angle B is. Well, in this diagram, we have arc CB and BJ, and together with the arc we want to find, they make a complete circle. So the arc we're looking for is 360 minus our 2 other arcs, 114 and 74. And when we subtract those, we end up getting 172 degrees for our arc. So now that we know our arc and we want to find our inscribed angle, the angle is equal to half of what the arc is. So our angle is angle B We take 1/2 of the arc, which is 172, and 1/2 of 172 gives us 86 degrees. All right, so let's look at number 10. Number 10, it wants us to determine what the measure of angle D is. And D is an inscribed angle because its vertex is on the circle. And the arc that's associated with this is CB. Now, there are a couple of ways to do this, but most people will prefer to find this arc and then solve for the missing arc and then solve for the angle. Okay, I will show you both ways, but we're going to do it the way most people would to start with. So if I want to find this arc BC, what I need to do first is find DB, because I already know what DC is. Well, DB is opposite of the inscribed angle, 59 degrees. So we know that this arc must be equal to twice what 59 is, which is 118. Now to find this arc, we know this arc's 118 and this one's 112. So we take 360 minus 118 minus 112, and we get that our arc is 130 degrees. So now since we know this arc, we can take half of that and find our inscribed angle. So we take 1/2 of our arc, which is 130, and we get 65. Now the other way you could have done that, if you have 112 here, you could actually find what angle B was by dividing 112 by 2. And when you do that, you end up with 56. So that would have been a 56 degree angle. And then to find angle D, you would have taken 180, because that's what a triangle adds up to, and subtracting 59 and 56. So the measure of angle D would have been 65 degrees either way. So there's a couple different ways to do that. So just, just be aware of how each one of those can be found. All right, so now moving on to number 11. We're not going to do number 13. I never taught you how to do number 13, so we're going to, avoid that one. But number 11, what type of angle do we have on number 11? Well, our vertex is on the outside of the circle, so that means it's an exterior angle. Now, an exterior angle, the formula for finding an exterior angle, we take our bigger arc minus our smaller arc and divide by 2. So in this case, 167 is our bigger arc and our smaller arc is 67. So we take 167 minus 67 and then divide by 2. So 167 minus 67 is 100. Divided by 2 gives us 50. Number 12. Number 12, if we look at our vertex is inside the circle, but it's not at the center. So this is an interior angle. And when we have an interior angle, in order to determine a missing measure, we need to take half of the sum of the two arcs. So what we do, we take half of the sum of these two. So we do arc plus arc divided by 2. So our arc 115 plus 59 divided by 2. 115 plus 59 gives us 174. Divided by 2 is 87. Number 14. Number 14, our angle has a vertex that's outside the circle. So this is an exterior angle. So in order to determine our exterior angle, we do big minus small divided by 2. So our big arc is 160, our small arc is 50. So we take 160 minus 50 divided by 2, and we get 110 over 2, which is 55 degrees. Okay. All right, so flipping on over to number 15. What I want you to do, I want you to try 15, 16, and 18 on your own. You don't have to do 17 because, again, I did not show you how to do those. So 15, 16, and 18, try those out and come back and check your answers. All right, so let's look at number 15. Number 15, our vertex is outside the circle. So that means this is an exterior angle. So to find an exterior angle, we take our big minus small and divide by 2. So our large angle is 146, minus our small angle, which is 80, and then divide by 2. 146 minus 80 is 66, divided by 2 gives us 33 degrees. Number 16, our vertex is inside the circle, but it's not at the center. So this is an interior angle. So to find interior angles, we take our 2 arcs, add them together, and divide by 2. So we take 155 plus 57 divided by 2. So that gives us 212 over 2, which is 106 degrees. And number 18, you see that your vertex is outside the circle. So that's an exterior angle. So you take your big arc minus your small arc divided by 2. Your big arc is 158 minus your small arc of 78 divided by 2. So that gives you 80 over 2, which is 40 degrees. All right, and there's 2 last ones here, number 19 and 20. So number 19 and 20, it both wants us to solve for x. Now, if you look at number 19, you see the angle K, which is associated with 8x minus 11, is an inscribed angle. So we need to figure out what that angle is before we try and solve for x. Well, we have an arc here of 154, and we know that our angle in an inscribed angle situation is 1/2 of the arc. So our angle, 8x minus 11, must equal 1/2 of 154. 1/2 of 154 is 77. Add 11 to both sides, and you get 8x equals 88. Divide both sides by 8, and you get x equals 11. And then finally, number 20. Number 20, you see here that we have -3 plus 35x and 27x minus 3 on the arcs. And you'll also notice that we have a diameter here. Well, if we have a diameter here, we know that we have 2 semicircles. So if you look at this arc and this arc, what do they equal when put together? Well, you should see that those are equal to 180. So we can add these 2 arcs together and set them equal to 180 to solve for x. So 35x plus 27x gives us 62x. -3 minus 3 gives us -6. Add 6 to both sides, and you get 62x equals 186. divide both sides by 62, and you get that x is equal to 3. And that's going to do it for this video, guys. I hope that in combination with the video on identifying parts or types of angles and circles, that this helped quite a bit. We will do more work with these and do some more practice just to make sure we have the hang of it. So thanks, guys, and I will see you in the next video.